So yeah, you can't put the squared tucked in like that. You'll have to group your sign x over 3 and then square it all together. Also, make sure that you close 2 sets of parentheses, one to close the x over 3, and then one to close the sign that you grouped and squared. So it says, at an intersection, cars turn left at a rate, so this is already a rate, in cars per hour, so I'm going to label that here. This is cars per hour. Okay, then it says for 0 to 18 hours, the graph is shown above. Part A, to the nearest whole number, find the total number of cars. This is cars per hour. I want the total number of cars. What am I doing for part A? An integral. Very good. I actually haven't done it yet, but we'll see. And then it does say to a whole number, so you'll want to make sure that you round it. So math 9, 0 to 18, and then y1 dx. Is that what you got, 1657?
Yeah.
Okay, good. Good, so it's 1657.8237, which is going to round to 1658 cars. What'd you say, Marisol?
You put it in y1, right?
I did. And you only have one equation on this one. You don't want the integral. Oh, you put the whole thing in the square root. Okay, part B. Read through it. See if you can figure out what to do. Part B is a little tricky here. Okay, so for part A, you would have gotten 2 points. 1 for setting up the integral, and then 1 for the right answer. Okay, what do you need to do for part B? Yes. Okay, look. Okay, look at your graph. They said they'll consider turn restrictions when L of t is greater than or equal to 150. What should you do? Graph 150 and then see where it's greater than that. So I'm going to draw in a line at 150 here. Okay, this is y equals 150. And then if I want my rate to be greater than that, I'm going to find these x values. Okay, now in the calculator you can do that, but you need to adjust your window so that you can see everything. Okay, then it says after that, find all values of t where L is greater than 150, and then compute the average value. So I need to find these numbers, and then I'm going to find the average of that afterwards, yes. So in my calculator, I already have mine typed in. I'm putting 150 right here. Then I'm going to go into my window. I'm going to make it from 0 to 18, just like they told me to. And then I'm going to adjust my y's to match these y's here from 0 to 250. Make sure that you're typing in your domain on x min and max, your range on y min and max. Okay? So there's my graph. And then what second y value did I forget to input? Oh wait, I did put it right there. Okay, and then you're finding where they cross. So second trace 5 is intersect. And then enter, enter, enter. First one is something, thinking for 100 years. Oh, what? Second trace 5. Yeah. 12.428, and then what's the other one? Okay, and then 16. And then from there, you need to go back and find your average value. Oh, there we go. Okay, 12.4283. And then second trace 5, enter. Okay, good. And then your average value, you do 1 over 16.1216 minus 12.4283. Then the integral from 12.4283 to 16.1216, and then your L of t right here. Okay? Now, actually, I didn't really fully answer the question. It asked find the values of t where it's greater than that. I really need to write this as an interval. So I'm going to put 12.4283 to 16.1216. Okay, as an interval. Because I can't just only find the x's, I need to say like between them, right? So that would be the first part of my answer. This is the second part of my answer. And what does it come out to be, 199? Point, and then it's 426. Now that would be in cars per hour. Because remember, if it's average value, your units stay the same. Okay? Okay, then the last part says traffic engineers will install a signal if there's any 2-hour period where the product of the number of cars turning left and the total number of oncoming cars straight through the intersection is greater than 2,000. Then it says 500 oncoming cars travel through the intersection. Does it require a traffic signal? Okay, so I want you to try to write this thing right here. I want the product. What am I doing? Multiplying, right? What two things? The total number of cars. That's an integral. And what? The total number of oncoming. And it tells me how many are oncoming. How many is it? 500. So what I need to do is see if there's an interval where the number of cars, we'll say from A to B, has to be a 2-hour period though, of L of t dt, multiplied by 500 has to be greater than 200,000. Okay, so just kind of think through that. I have a product of the oncoming cars, which they ended up telling me, and the total number of cars, that's my integral. Now think about, if I want this times 500 to be greater than that, can I divide to get rid of that? Yeah, I'll finish it in the video. Bye! What's up? More calculator issues?
Second trace
5.
Enter.
Okay, this was happening to mine too. Is it saying like error or something? So what I ended up doing is do second trace 5 and then just move your little sticker over and then it works.
Oh,
I don't know why it was doing that. It was doing the same thing for me too.
Okay.
But if you just kind of move your cursor around, it will find it.
Alright, lit.
Yep, very lit.
So,
For me?
did it. And then this video wasn't up. Me and Camille looked for it and it was not.
It actually just uploaded. That one I thought I'd uploaded and apparently I didn't. So it's uploaded now. Then this is FRQ number 1.
Dang, I'm still not even out of grade.
You're almost there. You have what, one more?
Can I get one more that I can do?
So you want this one plus one more?
Well, I have this one plus
Or that one plus one more? Okay. Yes, ma'am.
But can you do something that's already in the video app so I don't have to wait for anything?
Yeah, you can just pick one over there.
Well,
If you want one on like a certain topic,
where are they?
they're on the crate on the left. I might have done a few of them, but it's mostly blank.
Can I get all the
For the study sessions? Sure, they're all in this crate right here. So you can just pick which ones you want.
Miss Joyner,
Yes.
can I, the test we talked about today,
Yes.
can I get
Here.
Where did I put it?
you said you put it on the desk.
I know I did, and then I actually moved it like literally today.
Are you going to be here now?
Where I put it. I will be, yes.
I'm going to come and ask questions.
Okay, cool. Yes.
I know you have a study session today, but when can I do my test questions?
You can do them today after school. I'm actually gonna video. Here you go, Kelly. I actually already videoed the study session, and I'm just gonna play it so that I can help people correcting tests.
Oh, are you serious?
So you can do both.
Alright, clean.
Yeah.
Can I use a paper today's study session?
Sure. It's in that crate. It should be the very last one, kind of at the back.
Wait, so we just come here and grab the paper for the study session?
Huh?
Like, the paper that's like blank, and then we watch the video to fill it out?
Uh-huh. If you can't do it on first, we'll correct it.
Okay. And what if I have another one that's blank, and then
You can just do it. All the videos are on the website.
okay, alright.
All of them are on there.
I have a question on this one. Can you use like the actual change instead of doing like the actual
Another song's shorter.
Like where these would be at the times.
and I can you back to the
If it said like the only time I can think of where you might have to do that is if it was like one of the ones with the integrals in it, where it was like f of x equals the integral of g. That's maybe where you could have to do it, but I would say usually I don't think I've seen that on there. Maybe more than like once or twice. If it said the average rate of change of f time, you could be doing that. Or let's say if they gave you the velocity equation and they asked you for the average rate of change of acceleration, that could make you have to do that. But I wouldn't expect, usually if it's average rate of change, they're not trying to trick you. That's like just the easier part of that question. Welcome. Got it? I'm going to just finish the video. Do you care? You're fine. Okay. So we want to just basically figure out, is there a 2-hour period where this product is going to be greater than 200,000? So the first thing I'm going to do is divide by this 500, just to kind of get that out of the way. So really, the integral part itself only has to be greater than 200,000 divided by 500, which is 400. So if I can find a 2-hour period where L of t's integral is greater than 400, then they're going to need a sign. So I'm just going to pick the biggest integral. It looks like the values are the highest between like 13 and 15. So I'm just going to try that and see if it works. Math 9, 13 to 15, alpha trace y1, dx boom. And if it comes above 400, which it does, then they're going to need a traffic signal. So 13 through 15 would be my justification that on this interval, my cars coming through is 431. I multiply that by the 500 of oncoming cars. That exceeds this value. So I would say, yes, it does require a traffic signal. Hang on just one second, okay? So integral 13 to 15 of L of t dt equals 431.9314, which is greater than or equal to 400. So the traffic light is required because 431.9314 multiplied by 500 is greater than 200,000 on that interval. Okay. And then your breakdown for points on that last part, it looks like you got 4 points. You had to consider that you needed it to be greater than that value, which we already did, and you had to find an interval, and then you had to explain it. So, okay, good job.
Is that the only interval where it's greater than?
There could be other ones, you just have to kind of play with it and see. Probably if you went like